Hi, good evening. So I'm going to show you a little bit about Jakarta EE Security and how it can help you make your applications more secure and what's been introduced with Jakarta EE 10, as well as some of the new features that we can probably expect for the next Jakarta Security version. First, agenda. We'll look at the motivation, why to use security in cloud applications, some common use cases, the free Jakarta Security. Okay, yeah. So now I hope you also see the screen. So we are going to look at the motivation for applications in the cloud, common use cases, the Jakarta security specifications, what the latest release brought, and what we may expect in the future. Depending on the time, I may show some code briefly, and then if there's time for questions, you would be able to ask some of the questions. So first, a little bit about myself. I'm a Java and Jakarta EE expert. I work as a consultant and occasionally also as coach for Agile or DevOps or other optimizations. I work in a lot of open source projects. I'm an author and also regular speaker, and I'm the maintenance lead of 2 Java standards, and I'm currently the committer representative in the Jakarta EE specification committee. Yeah, the title is inspired by what some of you may probably know from the famous Columbo episode, and there are also a couple of other movies more for the generation Z by Netflix or HBO. So where do enterprise applications run keeps changing, especially with rising costs in many companies. They also may question the need to have their own data center. So in some cases, there may still be data centers inside the application in banking or other security critical cases, while in others, it may be more efficient for them to run it in the cloud. The applications also change in the way that they are distributed. That can either be a monolith or a collection of microservices. It can be in a container or even so-called serverless. And these factors, of course, drive the complexity of the application as well as the security concerns. So let's look at the example of deploying on-premise within a corporate network. Usually the authentication also happens against corporate identity systems. It may be a corporate single sign-on or even separate identity stores. Usually relying on either SAML or basic auth. If the application gets deployed into the cloud, then of course there can be one or several cloud vendors to control the network. There may be external identity systems, including social logins, for example, Google or Microsoft or other logins. Usually it's based on REST, at least in most of the cases. The identity propagation may also use SAML, but more often it's something like OAuth 2 using OpenID Connect and JSON Web Tokens. And there's, of course, more interactions, especially if an application becomes more popular. The authorization can be from multiple identity providers. And of course, secrets also need to be encrypted so they don't get into the wrong hands. If such cloud application gets segregated into microservices, then of course the boundary of the application changes further. You need to check whether to identify each time, especially if an application is distributed and shared for scalability. Not only in recent days, of course, it becomes more and more important where the cloud is hosted, and not only the recent activities and issues between Russia and Ukraine, for example, caused many companies to simply having to abandon their data centers and not even offer data centers in countries where they probably had outsourced before. So of course, it's especially important when you're sharing your secrets and your identity store in the cloud, where that cloud instance is actually located, where it may be compromised. Each application may manage its users or use externally managed user stores to authenticate those users against one or several identity stores, supporting either basic auth or OpenID Connect. You want your application to handle authentication events, for example, login or logout, as well as any not authorized for a particular application or part of the application events. And the application should have a easy to use portable authentication API, regardless of the individual identity store that's used underneath. So here we have several stages from development to test, integration, production on-premise, as well as moving the application to the cloud. The application always has to be able to determine the identity of the caller or user, as some frameworks call them, as well as all the groups that the users belong to, and know the user identity regardless of the underlying identity store. So even if the identity store should change from one system to another, the identity information should be consistent. The security context allows an application to determine those user attributes consistently through a well-determined API. The user, the groups and roles that user belongs to, and any identity provider used by the application, as well, regardless whether or not it's a local or a remote user or even a virtual user. So let's look at Jakarta EE Security. The security specs in Jakarta EE are currently a bit of a trinity, if you like. They consist of Jakarta Authentication, Jakarta Authorization, as well as Jakarta Security. They're all based on common principles. One is trying to simplify security programming models, because sometimes security frameworks in the past were often seen as cumbersome and not so easy to deal with. Making it easier for developers to manage security, and layered APIs sitting on top of each other. So the three that I just mentioned are layers where the security itself, the Jakarta Security API, is usually application facing, while the others are delegated to. So they're more SPI-like, and not every application may always directly talk to them. And wherever possible, this should be wired by CDI. Jakarta EE supports both a declarative security configuration as well as a programmatic configuration at runtime via APIs. Now let's look at Jakarta Authentication. It's a portable authentication mechanism abstracting the identity store against which the application authenticates. It's relatively simple to configure. It's quite extensible. For example, it was already possible to support protocols like OAuth in the past, and with Jakarta EE 10, some of that already comes out of the box. It produces a consistent representation of an authenticated subject. It supports the authentication events like login, logout, no permission, etc. And it's an evolution of a GSR in the Java community process that was started under the GSR number 196. So it has been around for quite a while. Now, let's look at OpenID Connect. It's an authentication protocol that was built on top of OAuth 2, supporting session management for single sign-on and sign-out. In addition to what OAuth 2 already provides, it adds a new token type called identity token. And it offers services for user info, discovery, and for client self-registration. There are several specs for each of these. And it's been supported by several vendors like Google, Microsoft, and others. So it has been widely adopted and is usually the most common use case on top of OAuth 2 by now. So what does that mean for the application? It makes it easier all the way from development stage to deployment in the cloud, to have a consistent API to abstract that identity store and authentication mechanism. And of course, it should also be easy for the DevOps team to configure the application according to the individual stage and location. The next lower level spec is Jakarta Authorization. It provides a low-level SPI type of spec for authorization modules. It offers several SPIs for authorization policy, configuration of such policies, and a factory to create or retrieve existing policy configurations, as well as another SPI for the policy context. So here's an example. With the servlet spec, in this case, there are also other use cases under Jakarta EE, but for the sake of simplicity, servlet is usually the easiest use case that many others, including, for example, the likes of Spring MVC, also build on top of. And then we have Jakarta Security, which holds the other two together and sits on a somewhat higher level, where the application usually deals with, or also developers, while some of the others are then called and delegated to by Jakarta Security. It exposes the authentication mechanism to the application. It defines an API for identity store, for security context, and for the role permission assignment. So what is the identity store? It abstracts the identity storage used by the application. It's fairly simple to configure, and it supports a large number of identity stores that are already built in, including LDAP or relational databases, as well as cloud-specific social logins or identity providers in the cloud. Those identity stores can be ordered, allowing to support multiple identity stores with one that may act as a fallback. In Jakarta EE 10, it supports OpenID Connect. And the API is always consistent, regardless of whether you're in the cloud or also regardless of the individual containers and vendors, making Jakarta EE more flexible. So you don't have to worry if the vendor of your application server should change for some reason, and you build on a standard like Jakarta EE and Jakarta Security, then of course you don't have to rewrite all your applications. The identity store exposes the user's identity, the identity provider that's used, and which groups or roles that user belongs to. So here's another servlet example. Now using Jakarta Security instead of the lower level SPIs. So all the three specifications have been updated in Jakarta EE 10 that was recently released. Jakarta Authorization has changed a bit less than the others, which is why the version number was only upgraded from 2.0 to 2.1. Here are some of the features that changed or were improved. The policy configuration can be retrieved without state requirements. So that makes it easier in a stateless environment to use it. The policy configuration also got some additional methods to read permissions. And there's generic support for get context. Jakarta Authentication was upgraded to version 3. So it changed a little more. Here also generics were added to the API. Methods to add or remove a single server authentication modules are offered. It fits in with the servlet container light profile, which was added to Jakarta EE 10. The password validation callback has been clarified and improved. And wherever security manager is used, it's marked as deprecated, given that JDK 17 and beyond plan to remove that from the JDK in the future. So in very soon in newer releases, it may not behave as it did before. It's probably going to be a no-op, and at some point it may even be completely removed, and that's why it's marked as deprecated now, and that means there will also have to be some substitution in the future. Whether that will be in Jakarta Security and the security specs or elsewhere remains to be seen, but yeah, the situation is a little bit similar to, for example, if you remember when some of the JAXB and XML bindings were removed from the JDK and had to be introduced as a Jakarta EE standard. In Jakarta Security, the version number is also 3.0. And there, the most significant addition and improvement is the authentication mechanism for OpenID Connect. Now let's look at what this means from an application point of view. So here, basically, it's the same servlet security that we saw earlier, but with additional OpenID authentication mechanism and all the relevant properties. Some of them, of course, you would normally try to use expression language or other ways to stub out some of the secrets, for example, and similar information that you may not want to have in your code, but rather externalize it. And in future versions of the Jakarta security spec, we also hope to make use of the Jakarta configuration as soon as Jakarta configuration becomes available for the Jakarta EE platform, which we hope will be in the next version. There are a few other additions besides the big change with OpenID Connect. The caller principal is now serializable. And the CDI beans got a dynamic interceptor. So I guess we can probably look at a bit of code. Okay, I hope the font is okay. So most of these examples are from our book. I will also mention it on the next slide, so you can check all of these out from GitHub and play with them. So here is an example for an identity store. And that's how to use it in a servlet. Here we have another example for custom authentication mechanism that implements the HTTP authentication mechanism. And again, a simple servlet example case. Here we have another example for an authentication mechanism. Combined with a customized identity store. And another test servlet. Yeah, I will show you the pointer to the GitHub repository. So as mentioned, these examples are from a book that Arian Theo, who is actually Greek. So those of you who are more comfortable speaking Greek, he can probably also answer some questions in your native language, while Arian and I don't speak Greek. We only speak German, English, and Dutch. There's also a Twitter user. Hopefully, Twitter will still be around for a little while. Then you can, of course, follow the book. And if there are changes in the book, feel free to follow our Twitter account. It's also maintained mostly by Theo, by the way. So I guess if you ask him questions in Greek, you may also be able to get an answer there. Yeah, and so here's the link to the book. And here's the mentioned GitHub repository with all the examples. So there are also examples for other chapters, but since they don't relate to the Jakarta security specs, I don't have time to cover them here, but we also covered other related frameworks like Spring Security, Shiro, or Keycloak. So yeah, feel free to check out the examples besides some of the other examples that Ivar provided, which you can see here. So that Jakarta.ee is the main entry point. Then for each of the three specifications, there are pages with the most recent versions. And Ivar, who sometimes holds this talk together with me, created some additional security examples. So you can also check out his example repositories or those from our book, or a combination of both. So let's see, are there questions? Wait, oh, okay. I think I saw it. How easy is for someone with least knowledge of front end to learn Jakarta EE? Okay, so I'm not sure, is the question because most of Jakarta EE is not traditionally front end. So was the question how easy it is for someone who has mostly front end knowledge, like Angular, to learn Jakarta EE, or? Yeah, so usually Jakarta EE, of course, tries to make it easier, but it's not really mainly a front-end technology. So it may, of course, be a little different from Angular or JavaScript. Although there are several specs, especially Java server faces, that interact rather well with Ajax and JavaScript. So you may find some of them familiar if you come from the front-end side, while other areas may be a little more complex or seem less familiar. I hope that answers the question. Otherwise, please feel free to also contact us either on Twitter or either on the Twitter handle of the book or myself via Twitter. Okay, so yeah, okay, then you're welcome. If there are no other questions, then thank you very much for attending or watching the presentation, and I hope you find some use and make your applications more secure by using Jakarta Security and the related specifications.